Okay, this will be the next video in the trig equations unit. We're going to start to talk about some of the identities. I want you to have, I know you have a piece of paper with the unit circle. I would like you to have a piece of paper for some of these identities and formulas, okay? All right, now, these are your base trig identities, okay? Now, what you want to do is have an idea of, as we move into later on into verifications, of what these things mean. So this means this. Now, if I were to move the cosine over here, this also means that, and I'd like you to have these down as well, that sine squared of theta is 1 minus cosine squared of theta. If I were to move cosine over there, I could also use the identity that it's 1 minus sine squared of theta. Okay, so all three of those go together. Likewise, that equals that. If I move the 1 over to the other side, that would be secant squared minus 1. Okay, if I move the tan over, 1 is equal to secant squared theta minus tan squared theta. Once again, you should have all of those, okay, down from that standpoint, okay? Same thing here. Move the 1, we know that cotangent squared theta is equal to cosecant squared theta minus 1. And then also, if I were to move cotangent, cosecant squared theta minus cotangent squared theta equals 1. Here are some of your double angle identities, okay? All right, once again, you're given these, okay? And we'll sort of show how those are applied later, all right? They can help you solve equations. They can also help you find values, okay? And we will get into that, okay? All right. I have drawn the unit circle back up for us as we've been working on last time, okay? All right, so you should have this as well. So it's like you should have two pieces of paper out to help you solve. All right, so what we're going to do is we're going to solve, all right, from the interval of 0 to 2 pi. All right, now, as far as this goes, this is actually pretty easy. Okay, like we talked about last time, I replaced the trig function, okay? We'll talk about the x deal in a second. But I'm going to go ahead and wipe this out for right now and have x plus square root of 2 over 2 equals 0. I would subtract by square root of 2 over 2. Okay, so I get x equals negative square root of 2 over 2. All right, bring my cosine function back. Okay, all right, and do the inverse. Okay, so where will the values be negative square root of 2 over 2? Okay, well, that's clearly going to be something involving this one because that's the only one that has square root of 2 over 2. So that would be the pi over 4 triangle. Now, since we have a negative cosine, where is cosine negative? Cosine would be negative here and here. So I would be looking at the answers of 3/4 pi and the answer of 5/4 pi. Now, as you remember, this x over 2 is really what we're solving for. So I would have this, all I'm going to do is set this equal to x over 2. And I'm going to cross multiply. So that would be 6 pi over 4, or x equals 3 pi over 2. I cross multiply there, that's x equals 10 pi over 4, or x equals 5/2 pi, okay? So the double angle there really didn't have an overall effect, major effect for us, other than the concept that at the end, we just had to basically cross multiply that and solve, okay? Let's go ahead and try another question here, okay? Let's go ahead and try another question here. All right, so here's our second question, okay? All right, so what I would do is simply, I can set x equaling the sine of x over 2, all right? So I got x plus 1 equals 1/2, subtract 1, subtract 1, x equals negative 1/2, bring back the sine, and I want to find it at negative 1/2. So what would that be? That would be sine O over h, so that would be the pi over 6. Now, since this is negative, I got to look at where sine is negative. Well, sine is positive here or here. So I want to use an answer of 7 pi over 6 and an answer of 11 pi over 6. Now, once again, we're dealing with the little half angle here. So what I would have to do is just cross multiply that. So that's going to be 14 pi over 6 or 7 pi over 3. Okay, same thing here. I got x over 2 equals 11 6 pi. Cross multiply that. That's going to be 22 over 6 pi or 11 thirds. Okay, so those would be your answers. Nothing overly difficult. Okay, what I would like you guys to do is go ahead and pause, all right, and go ahead and complete this one. Okay, all right, so pretty simple. I want to select cosine x over 2 as x. All right, so x minus square root of 3 over 2 equals 0. Add. Okay, so x equals square root of 3 over 2. Bring back the cosine. All right, so I want to find where a is square root of 3 and h is 2. That would be the pi over 6 triangle. Okay. Now, since this is positive, I just got to find out where cosine also is positive. It's going to be 11 pi over 6. Okay. Now, since I have those as halves, I'm going to have to go ahead and set them equal to halves. Okay. So cross multiply that. That would be 2 pi over 6 or pi over 3. This would be 22 over 6 or 11 over 3 pi. Okay, those would be your answers for halves. Those are pretty easy. Okay, nothing really overly new there. Okay, other than setting the thing at the end. Now, let's go ahead and get into our identities. Okay, the first type of thing I want to talk about is when you have one of the identities squared, or one of the trig functions squared, and the second one not. Okay, so what you want to do, all right, is you want to substitute for the squared identity. Okay, so what I want to do is look for my identities. What does cotangent squared equal to? Well, when I go and look at the identities, I see that this is basically equal to cosecant squared minus 1. Okay? All right? Now, there's nothing to multiply here, so I got cosecant squared minus 1 plus cosecant x. I'm going to bring that 1 back over, so that would be minus 1 equals 0. So let's organize this a little bit better. Okay? All right? So I got cosecant squared x plus cosecant of x minus 2 equals 0. Okay? Now that I've got everything in one trig function, I can roll with that. Okay, where I can substitute cosecant of x for x. So this is going to be x squared plus x minus 2 equaling 0. And we worked on this last time. It's a simple factoring of x plus 2x minus 2. I would set those equal to 0. So I got x equaling negative 2. I would add 1. That's x equaling 1. Okay? Bring back the cosecant function. Cosecant of x equaling negative 2. Cosecant of x equaling 1. Okay? I am doing the inverse. Okay? Of that. Okay? Same thing for this one. Cosecant inverse of 1. Let's start where it's negative 2. Okay? All right? So remember, cosecant, that would be negative 2 over 1 or h over o. Do I have a situation where the h is 2 and the 1 is o? H is 2, 1 is o. It's that one. Now, since I have a negative, this is like sine. All right, so I got pi over 6 for this one. I got pi over 6 for this one, but I got to figure out where sine is negative. Sine is negative in these two quadrants. So the first thing I got is 7 pi over 6 and 11 pi over 6. All right, because sine and cosecant very much the same. All right. Cosecant of inverse being 1, okay? That links to sine, okay? So where is that going to happen? That's going to happen at pi over 2. Remember, the axis things for 1 and negative 1 are very much the same, okay? So those would be your 3 answers for that question, okay? All right, let's do another one together, okay? So what I want to do here is I want to sub for the cosine squared. And what that equals is 2. All right, now I got to substitute. I got 1 minus sine squared of x minus sine x minus 1 equals 0. So I'm going to have to distribute, so that's 2 minus 2 sine squared of x minus sine of x minus 1 equals 0. Okay, now that I got everything, let me go ahead and reorganize this. So I got negative 2 sine squared of x minus sine of x. 2 minus 1 would be 1. Okay, now I want to set, you could have done that actually back here. I probably could have done that at that step. It might have been easier. Sine of x equaling x. So I got negative 2x squared minus x plus 1 equals 0. Okay, now, I don't usually like to factor with a negative squared, so I'm going to take that negative 1 out. So what I got is 2x squared plus 1x minus 1 equaling 0. Okay, this is a very simple factoring question. I can do almost a guess and check to figure this out. Okay, so I got to end up with positive. So I think this is going to be plus 1 and minus 1. Okay, so the guess and check there is that times that would be 1, that times that would be 2. Combine those, that's good. Okay, now I want to set these equal to 0. So I got 2x minus 1 equaling 0, x plus 1 equaling 0. Okay, so this would be 2x equals 1, x equals 1/2. Okay, this would be x equaling negative 1. All right, now what I want to do is I want to go ahead and bring those back here. I want to bring those back. So I want to find the sine inverse, basically, of 1/2. And I want to find the sine inverse of negative 1. Okay, so O over H. So O over H, that's this pi over 6. So I'm looking for where sine is positive. So it is those two. So my first answers are pi over 6 and 5 pi over 6. Where is sine negative 1? Sine would be negative 1 only down here at 3 pi over 2. And those would be my answers for that. Okay? So what I would like you guys to do is go ahead and pause your video and go ahead and try these. Okay? All right? So I'm going to substitute for tangent squared. Tangent squared is equal to secant squared minus 1. Okay? All right? And now I got everything working here. There's nothing to multiply, so I can just do secant squared minus 1 equals 1 minus secant of x. Okay? So I'm going to go ahead and say secant of x is equal to x. Make things easier. So I got x squared minus 1 equals 1 minus x. Okay? I want to bring everything back over. So that's x squared. Negative x would come over as positive. This would come back as negative. If I combine those two, I get negative 2 equaling 0. Okay? Once again, a very simple factoring deal. X, all right, this has got to be x plus 2. This has got to be minus 1. Okay? All right? And so I set these equal to 0. That's x equals 1. Set this equal to 0. That's x equaling negative 2. Okay, I'm bringing back secant of x equal, or secant inverse to equal 1. I'm bringing back secant inverse to basically equaling negative 2, or h over a. Okay, now the 1, all right, that's that. If I look at cosine, I've got that is right here. So that is going to be 0. Okay, I got an answer of 0 for that. That's pretty simple. The negative 2 pi, I'm looking for 2 over 1, where the hypotenuse is 2 and the adjacent is 1. That is going to be this. Now that's going to be pi over 3. The problem is it's negative, so I got to find out where is secant going to be negative. Secant is going to be negative in these two quadrants, so I would choose 2 pi over 3 and 4 pi over 3. Those would be my answers for that question. Okay? All right? Now, let's talk about when you have the trig functions and they don't have a squared. Okay? So when this happens, when you don't have no squared trig function. Okay? No squared trig function. So this is the second process here. The other one we were able to easily substitute with. This one we could not. So when we do this, what we're going to do is square both sides. Okay? All right? I want to square both sides. All right? So, all right, so that's going to just be 1 over here. Okay? Now, if you got to do a box for this, that's fine. You can treat them as x and y if you want to do that, but let's go ahead. I got cosecant, all right, minus cotangent, cosecant minus cotangent. So that'd be cosecant squared minus cosecant and cotangent. This would be minus cosecant and cotangent, and this would be plus cotangent squared, okay? So what this turns into is cosecant squared, all right, minus 2 cosecant cotangent, okay, all right, plus cotangent squared, equaling 1. You know what? Let's not do it that way. Let's do it a different way. Cosecant x minus cotangent of x equal 1. All right, before we square that, let's move that to that side. So I got cosecant of x equaling 1 plus cotangent. Yeah, that's better. Okay, so what I want to do is move, probably the better direction was to be move the trig function to each side, move the trig functions to opposite sides, and then square both sides. Okay, that's probably going to be easier, to be honest. Okay, so I would end up squaring this and squaring this. This side's easy, cosecant squared x, okay? This side right here, I could go ahead and apply that with the box, cotangent squared and 1, or cotangent 1, so cotangent plus 1, so that's going to be cotangent squared, 1 cotangent, and 1, okay? So I would have, this side's going to be cotangent squared x, okay, plus 2 cotan of x plus 1. Now, what you're going to want to do is we're like back to the other one. What you're going to want to do, since we have this, the one that has like just the just this part, I'm going to want to make this into cotangent. That way I can then organize everything. So what I want to do is look at what does cosecant equal to? Or cosecant is equal to cotangent squared x plus 1. So I got this. Cotangent squared x plus 2 cotan of x plus 1. All right, now this might be the opportunity to like really just substitute cotangent now for x. So I got x squared plus 1 equals x squared plus 2x plus 1. Okay, now let's go ahead and bring this back. So I would subtract x squared, okay, and subtract 1. So that'd be 0 equals 2x, okay, because this is going to eliminate and this is going to eliminate. So very easy solving. I would have that, okay. So then I would bring cotangent back. Cotangent inverse. When does cotangent of inverse equaling 0? Okay, this is where you got to be really careful, okay. We have tan is 0, but remember cotan is the opposite of that. So what I want to look at is where is tangent undefined. So that answer would be pi over 2, okay, and 3 pi over 2. Those would end up being my answers for those, okay. Those ones are a little tricky. We're going to try another one here, all right, real quick, all right. Maybe a little less writing on my part. Okay, so this has already been moved, so I'm in good shape here. All right, I moved that. So what I want to do is square both sides. Okay, that's easy now. That's going to be tan squared. Okay, all right. Now, like I said, this might be something that you figure out when you square that. All right, secant plus 1 secant. So that's secant squared, 1 secant, and 1. So what that's going to turn into is secant squared plus 2 secant plus 1 equaling tangent squared. Now, since I have this here, I'm going to go ahead and sub out what tangent equals. What is tangent equals? Tangent equals secant squared minus 1. All right? Now, what I'm going to go ahead and do is I'm going to go ahead and sub out secant for x. So this would be x squared plus 2x plus 1 equaling x squared minus 1. Okay? Move that back over. That would be minus. That would be minus. Okay? That would be plus. That would be plus. So what I got here is I got 2x plus 2 equaling 0. So 2x equals negative 2. All right, divide by 2, I'd have x equaling negative 1. Okay? All right, now I can bring back secant, inverse secant, where it's negative 1. Okay, check the axis points. Now I want to check where it's cotangent or cosine. So this answer right here would just be pi. Okay, there's no other ones that would work besides that. Okay, so what I'd like you guys to do is go ahead and try this one. Okay, now everything's already been moved for you. Okay, so what I want to do, square this side, square this side. So that's going to be cosine squared x equaling, okay, if you do a little box down here, sine x minus 1, sine x minus 1. So sine squared minus sine, plus 1. Okay, so that's going to be sine squared x minus 2 sine of x plus 1. Now, since I got this little side here, I probably want to sub that out. Okay, so what we know is that this is going to be equal to 1 minus sine squared of x. So sine squared of x minus 2 sine of x plus 1. Okay, I'm going to say sine of x is equaling x. So we'll make this easy. So 1 minus x squared equals x squared minus 2x plus 1. I would subtract this 1 over here, and I would add this x squared. So what this is going to be is 0, 2x squared, all right, minus 2x. That would end up being 0, okay? So if I'm taking out a GCF here, that would be 2x and x minus 1. So I'm looking at 0 equaling 2x or x equaling 0. I would look at setting this equal to 0, which would be x equals 1. Bring back sine. So I want to do inverse sine of 0 and inverse sine of 1. Okay, well, inverse sine of 0, all right, that's just going to be 0 and pi. Inverse sine of 1 is just going to be pi over 2. Okay? All right, let's go ahead and roll into the last part of this, which is with the double angle identities. Okay? So what you want to do is sub for the double. Pick the same trig function for what's left over. Or not pick the same, pick the other trig function. Okay? Now, what I mean by that is, if you look down at your cosine of 2 theta, you got a lot of choices, okay? Doesn't matter as much here for sine, but you want to probably choose one that matches up with the other. Now, sine of 2 theta, this only matches up with 2 sine of theta, cosine of theta, okay? Sine of theta equaling 0. This is actually pretty easy. There is a common denominator here of sine of theta. So what I got is I got 2 cosine of theta minus 1 equaling 0. So I would set both of these equal to 0. Now, if you want to do the x and y deal, you can. Does not matter to me, okay? Whatever you find is easier, okay? So this one, I'm just going to real easy. Sine of inverse of 0. Got to do a little bit of work here. That's going to be 1 divided by 2. I want to do the cosine of theta of 1/2. So I'm doing inverse cosine of 1/2, okay? So let's find where the sine of 0 inverse is 0. That's going to be 0 and pi. Okay, 0 and pi. All right, 1/2. So where is the A1 and the H2? A is 1, H is 2 at pi over 3. Since it is positive, I'm looking for the other time where it's going to be positive, which would be here, which would make that 5 pi over 3. Okay? All right? All right, let's go to this one. All right? Now, as you can see here, I got cosine of 2 theta. If you look down at your identity sheet, you got a bunch of choices. Now, what I would pick is the one that matches with this other trig function. So I got sine squared. So what I would do is I would substitute for 1 minus 2 sine squared of theta. Okay? All right. Reason why I'm going to do that is I want to get down to one trig function. All right. So this is going to be sine squared, all right, plus 1 minus 2 sine squared. Okay. If you want to substitute for sine, you can. Sine of theta equaling x. So it'd be x squared plus 1 minus 2x squared equaling 0. Okay. So this would be negative 1x squared plus 1 equaling 0. Okay. If I solve here, I got negative 1x squared equals negative 1. I would divide by negative 1, so I got x squared equaling 1. All right, and then I would solve square root plus and minus. So I would have x equaling plus and minus square root of 1. Bring back sine inverse of square root of 1. Plus and minus square root of 1. Or 1, probably, sorry. Okay, so this would be x equals plus and minus 1. Okay, so I would take the sine inverse of plus and minus 1. So I'm looking for where it's both 1 and negative 1. That's pretty easy. That's going to be the axis points. That's going to be pi over 2 and 3 pi over 2. Okay, and that's going to be the answer for that one. Okay, what I'd like you to do is go ahead and pause your video and go ahead and substitute for this one, or do this one. Okay, now what would make sense here is that this other sign is cosine, so what I'm going to do is I'm going to substitute 2 cosine squared minus 1 for this. Okay, now there's nothing to multiply here, so I can just reorganize. 2 cosine squared plus 4 cosine, all right, plus 2. All right, with that. All right, now if you want to, you can substitute x for cosine, if that makes things easier for you. So it's 2x squared plus 4x plus 2 equaling 0. Okay, I want to make sure I wrote that problem down correctly. Yep, that's fine. Okay, so what I'd want to do here is take out the 2, so I'd be left with x squared plus 2x plus 1 equaling 0. So that would be 2x plus 1, x plus 1 equaling 0. So I would just set those equal to 0. It's the same thing. So it would be x equals negative 1, x equaling negative 1. So I would do cosine inverse of where it's going to equal negative 1. And the only thing that could be there is pi. Okay? All right, and I think that's it. Okay, so yeah, that was the second video for trig equations. A lot of this just takes some practice and some work, and if you work on that stuff, you should be fine.